Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. You can use the link in the description if you want to try this out on your own, and when you've got an idea, come on back and see if we get the same thing. All right, I'm going to start with a 0. Okay, 0 gives us 1. How about a 1? All right, so that looks like a non-repeating decimal. So maybe this is a square root function. Maybe this is trig. How about a 2? So it was up and then down. So now I'm thinking trig. How about a 3? That's basically negative 1. Let's do 3.14 since we're thinking trig. Yeah, and that's right on that negative 1. So we were at 1 at 0 and negative 1 at an approximation for pi. So that's making me think about the cosine, although the rest of the shape is looking a little strange. But let's just think about the cosine. So the sine and the cosine are these functions that give the x and y coordinates of where an angle intersects that unit circle. So here you're at the point 1, 0. And the cosine is the x. So that's why we have 1 at 0. When you get to pi, cosine, the angle moves all the way around here. This is the point negative 1, 0. So your cosine is negative 1. So that's why this made me think cosine. At pi over 2, right here, this is the point 0, 1. So there the cosine should be 0. So pi over 2, So maybe let's put in a 1.6 as an approximation. Whoa! So that's a very large negative number, negative 34. Huh. So let's see if we can I don't know, get a few more values to look at the shape of this closer to that pi over 2. So maybe 1.3 and maybe 1.4 and maybe 1.7. Yeah, so it looks like we have arms shooting up here, and that pi over 2 is maybe an asymptote. So this one is going up rapidly, probably to infinity. This arm over here going down rapidly, probably to infinity. Let's do some negative values. I want to get the full shape of this. Maybe you okay. That confirms it for me. Maybe you've got a hunch already. Let's do a negative 1. Whoops. Negative 1.3 and a negative 1.4. Yeah, and if we go on a little further, let's see, 4 and maybe 5. Yeah, and that's starting another one. So what we're going to get here, it's a little hard to see. Let me put in a couple more decimal values here, and maybe 4.4. So I think you can start to see the shape now. What we have are these sort of, almost look like parabolas, these shapes here, these sort of big curves. This one opening upward, then this one opening downward. You'd see another opening upward one over here and another opening downward one over here, and they would repeat and repeat and repeat. So if you haven't seen this before, it might be confusing. This is a function that's related to the cosine. So that initial hunch with 1 at 0 and negative 1 at pi, that's helpful. What we get at pi over 2 is infinity. And it approaches infinity both at the positive and the negative end. So what is causing that? Well, at pi over 2, the cosine is 0. And the way you get that sort of undefined point there is you have that on the bottom. So 1 over 0, that's going to be you know, the crazy undefined point. So I think we have 1 over the cosine. And that would still make sense with these other points we're seeing. So if the value of cosine is 1 at 0, 1 over 1 is 1. And at pi, same with -1, 1 over -1 is -1. So this is sort of that, 1 over the cosine rather than the cosine itself. The other name for this is the secant of x. So this is either 1 over the cosine of x or the secant of x. It's the same thing. I don't know how they've labeled it here. I'm going to go ahead and take a look because I don't think I need any further proof. The shape of this is telling me that it's the secant. Yeah, and they've put 1 over the cosine of x or the secant of x. It's the same thing. Let's go ahead and graph this one. Yeah, so you get those big loops from the top and big loops from the bottom, alternating with those undefined points where the arms go to infinity and negative infinity. Well, that was one we hadn't seen before. How did that go? Were you thinking trig? Let me know. Thanks, everybody.